concept of a mole is fundamental to a quantitative understanding of chemistry. If you want to collect and analyze numerical data involving a chemical reaction, then you must understand the concept of a mole. Well, what type of mole are we talking about here? The underground dwelling rodent type of mole? The skin blemish type of mole? The secret agent spy type of mole? Not exactly. In chemistry, a mole is simply an amount of things. Specifically, a mole is this amount, which is a whole heap of things. This number is huge. A mole is 6.02 times 10 to the 23rd things. A mole is 602 sextillion things.
Did you just say sex?
I did, but not the birds and the bees type of sex. This number, 6.02 times 10 to the 23rd, is known as Avogadro's number. It is named for this hunka burning love, Amadeo Avogadro, because of his work with gases. As you are well aware, atoms and molecules of a gas are extremely small. As we will see, the concept of a mole allows scientists to relate the mass of an atom or molecule to an amount of that atom or molecule. This is why when chemists do a calculation, they do it with moles. So what does it mean to have a mole of an element? Let's use carbon for our first example. If you were to look up the atomic mass of carbon on the atomic mass table or the periodic table, the listed mass would be 12.0. This number, 12.0, is meaningless without a label. The number given on these reference tables relates the mass of a substance to an amount of moles. If I have 12 grams of carbon, that means I have 1 mole of carbon. And having 1 mole of carbon means I have 6.02 times 10 to the 23rd carbon atoms. What about a different element, like silver, which has a symbol Ag? From the periodic table, I can see the atomic mass is 107.9, which means 107.9 grams of silver equals 1 mole of silver. This also means that if you have 107.9 grams of silver, you have 6.02 times 10 to the 23rd atoms of silver. Let's try a trickier one, oxygen. Remember, oxygen is one of the elements that is diatomic in nature. Don't forget your chemistry friend, Hofbrinkel. This means that the elemental form of oxygen is not just an atom of oxygen, rather it is a molecule of O2. Therefore, to get the molar mass of elemental oxygen, you will have to multiply the mass from the periodic table by 2. If I have 32 grams of oxygen molecules, then I have a mole of oxygen molecules. A mole of oxygen molecules is 6.02 times 10 to the 23rd oxygen molecules. Since 1 mole of oxygen molecules contains 2 moles of oxygen atoms, I would have 12.04 times 10 to the 23rd atoms of oxygen in 1 mole of oxygen molecules. The proper way to write this number in scientific notation is actually 1.204 times 10 to the 24th. All right, what does it mean to have a mole of a compound? Let's start by looking at good old H2O. To get the molar mass of water, we need to add the mass of 2 hydrogen atoms to the mass of 1 oxygen atom. Remember, these atomic masses are coming directly from the periodic table. 2 grams plus 16 grams gives me 18 grams of water in 1 mole of water. If I have a mole of water, I have 6.02 times 10 to the 23rd water molecules. Since a mole of water contains 2 moles of hydrogen atoms, I would have 12.04 times 10 to the 23rd, or more correctly, 1.204 times 10 to the 24th atoms of hydrogen. 1 mole of water molecules contains 1 mole of oxygen atoms. So there are 6.02 times 10 to the 23rd oxygen atoms in a mole of water. How about silver nitrate, or AgNO3? I'll need my periodic table or atomic mass table to find the molar mass of silver nitrate. Silver has a mass of 107.9 grams. Nitrogen contributes 14 grams. The compound contains 3 oxygen atoms. Since each oxygen atom has a mass of 16.0 grams, 3 oxygens would contribute 48.0 grams. When all of these masses are added together, we get a mass of 169.9 grams of silver nitrate in 1 mole of silver nitrate. A mole of silver nitrate equals 6.02 times 10 to the 23rd molecules of silver nitrate. 1 mole of silver nitrate would have 1 mole of silver atoms and 1 mole of nitrogen atoms, meaning there are 6.02 times 10 to the 23rd of each of those atoms. 1 mole of silver nitrate contains 3 moles of oxygen, so we would have 3 times 6.02 times 10 to the 23rd, or 18.06 times 10 to the 23rd atoms of oxygen in 1 mole of silver nitrate. Of course, the proper way to write this value is 1.81 times 10 to the 24th atoms. I hope this helps you wrap your head around the numerical concept of a mole. Next, we will use some mole facts to do some simple calculations.
Did you just say sex?